Solving, this is missing the word, rational inequalities. Not just solving inequalities, but rational inequalities. Okay, here's a procedure for solving rational inequalities. We're going to move everything to one side of the inequality so that its rational expression is less than or greater than 0. Okay, now I guess we're going to do something else before that. All right, so add or subtract the rational expression so that you have one fraction. Right? We spent some time adding and subtracting rational expressions. This is where you use the skill. Then we factor the polynomial expressions and then make a sign chart. Now you've done that too. Okay. So then we identify the appropriate interval to match the less than 0 or greater than 0. Now this you might not understand until you see it in action. So let's get it. All right, so here's the first example. So this is a typical rational inequality. So this 2 is in the wrong place. I'm going to move it to the left. So all we do is subtract. Then we're going to rewrite this as one fraction. So we need to find a common denominator. There's only one denominator, so the common denominator is x minus 4. We rewrite it as such. Right? So put an x minus 4 under the 2. That means I got to multiply the 2 by x minus 4. Go ahead and work it out. And then we're going to combine it, put it into one fraction. So it's x minus 2x, which makes negative x, and minus negative 8, which makes it plus 8. Okay. Okay, and then simplify that. So you get negative x plus 8 over x minus 4. And we want it to be less than 0. Less than 0 are negative numbers. All right, now we're going to make a sign chart for this. So we make a number line, and we want the values that's going to make this equal to 0. Each factor equals 0, rather. All right, so we need what? 4. 4 makes the denominator equal to 0, and 8 makes the numerator equal to 0. All right, then we make the signs. So pick a number over here, say 0, right? If I put 0 in the numerator, I get a positive 8, and put 0 in the denominator, I get a negative 4. So it's 8 over negative 4, making it a negative number, negative 2. Put a number between 4 and 8, say 6. So negative 6 plus 8 is positive 2. 6 minus 4 is positive 2. So it's positive. Plug in a bigger number, say 10. Negative 10 plus 8 is negative 2. Over 10 minus 4 is 6. Negative 2 over 6 is a negative number. Right? I'm not interested in the specific values. I just want the sign. Now, this is saying where the inequality is less than 0. So where is it less than 0? That means negative. So the negative regions are here and here. From negative infinity to 4 and 8 to positive infinity. And this is how we're going to write the notation, right? We always have a parentheses on a negative infinity and the positive infinity. And the 4 and 8 are not included in my solution. Okay. So we put parentheses, round parentheses on there. So that's my answer. This is new, this little u. I got scolded for not requiring you to put the u in there. So u, you're going to use u every time. You're not going to use the upside down version. Okay, whenever you have more than one interval, you're going to connect them with a u and not a comma. Okay, all right. All right, on to example 2. Same thing here. We're going to move the 4 to the left and then find a common denominator, which is x plus 5. And rewrite 4 with the denominator of x plus 5. So that means we got to multiply the numerator by x plus 5. Go ahead and distribute that 4. Okay, I haven't distributed this minus yet, but I'm going to do that now. So that becomes minus 4x minus 20. Combine like terms, 8 minus 20 is negative 12. And that minus sign on 4x becomes a negative 4x. Now we need to make a sign chart, right? What's going to make these things equal to 0? Negative 5 makes the denominator equal to 0. And negative 3, negative 4 times negative 3 is positive 12. 12 minus 12 is 0. So that's it. All right. Now, oops, I went ahead and pushed the button. So what is the sign in this region to the left of negative 5? If I plugged in negative 7, right? Negative 7 times negative 4 is positive 28. Minus 12 is a positive number. But the denominator, negative 7 plus 5, is negative 2. So I got a positive number in the numerator, negative number in the denominator gives me a negative sign for that region. What about here? So let's plug in a number like negative 4. If I plug in negative 4, I get positive 16. Minus 12 is a positive number. Negative 4 plus 5 is a positive number. So I got positive number over positive number. Okay, then plug in 0. That makes it negative 12 over positive 5, which is negative. Okay, now let's see what the appropriate answer interval. It says greater than or equal to 0, so we want the positive value. Okay, so the answer is negative 5 to negative 3. Whoops. Notice there's a different notation to either end. Okay, so let's see why they're different. Well, if I put negative 5 into that expression, it becomes undefined. So I definitely cannot include negative 5 as an answer. But this square bracket on negative 3 suggests that I am including that as part of the answer. Well, let's see why. If I plug negative 3 into the numerator, I get 0 in the numerator. Remember, that's why that was that boundary there. So why is that included? Well, 0 over 2, if I plug negative 3 in the denominator, it becomes 2. So 0 over 2 is 0. And there's an equal to bar on this in this inequality. So 0 is a solution. 0 is acceptable. So that means I have to include negative 3 as part of the solution. And that's the answer. So those are the two types, right? Either greater than 0 or less than 0. And that's it. That's the example. And I think that's it. Oh, this is a revisit on the solving rational inequalities procedure. Move everything to one side. Get it to this less than or greater than thing. Add or subtract a rational expression so that you have one fraction. Factor the polynomial expression. Make a sign chart. Identify the appropriate interval to match it. And that's it. Okay. And then, what's next? Another test. Okay. So this is the last topic before we take the next test. Okay. That's it. Bye-bye.